Okay, again, when I have x to the fourth, I have a graph that ends with a smile because it's positive. So it ends with the smile, and I have 3 humps because it's a 4, so there's 1 less than the degree of humps. So it looks like a W. But when it's a negative, it's going to end with a frown, and so I know that it looks like an M. With an odd degree, if I have 3, then I know if it's positive, it will end with a smile, and in this case, begin with a frown. Okay? And then, if it's a negative cube, then I know that it ends with a frown and begins with a smile. Okay? So, with that in mind, I have this equation up here. I know it's a positive cubic equation. So I know that it ends with a smile. Okay? Now, I also know that it has a max and it has a min. And to find out those points, right, derivatives are all about the slopes of the equation. The first derivative is all about the slope. So, when I'm talking about the derivative of this equation, I'm talking about the slopes at this point, at this point, at this point, at this point. But what the cool part is, when I'm talking about the slopes at this exact point, where it changes from positive to negative, then I'm talking about the slope at 0. The same thing when it changes from negative to positive. I'm talking about a 0 slope. So, the key here is to find the first derivative, which is 3 times 2, which is 6. Subtract 1 from 3, and that's 2. 2 times 1, or 2 times negative...
2 times 3 is 6.
Yeah, 3 times 2 is 6.
Okay.
And 1 from 3 is?
2. So then it just goes down. Okay.
Same thing here.
Okay.
2 times 16
is 36.
32?
32. Got
Right,
it.
okay. And then 1 from 2 is? 1.
1. So then it's just an x.
That's it. 1 times 24 is?
25.
24.
Oh, you said times. I'm going.
It's okay. And then 1 from 1 is? None. So there's no x.
Okay.
Okay? And then a 0x, x to the 0, 0 times 10 is 0, so there's nothing there anyways. So that's it. That's my derivative.
That's your derivative.
That's our basic power rule. Now what we do here is we want to set this derivative equal to 0. Because that's going to tell us where our maximum and our minimums are. That's going to tell us where the slope of this equation right here is 0. So when the slope becomes 0. And the only place it becomes 0 is when it changes from a positive to a negative, or from a negative to a positive, right?
0.
So that's where we want to know. We want to know those points. Those are specific points. So what we do is solve this. Now, if I could factor this, I would. I made this problem up, so I highly doubt it's factorable. But you know what will work is the quadratic formula. This is a quadratic, so we can use a quadratic formula to solve it. Remember, negative b plus or minus the square root of b squared minus 4ac all over 2a. So, whereas ax squared plus bx plus c equals 0. So a, b, c. So negative b, which is negative 32, plus or minus the square root of b squared, or negative 32 squared, minus 4 times a, which is 6, times c, which is 24, cool, And the discriminant's going to be positive, so that means it's going to be in the real realm, thank goodness. Because I got 24 times 24, which is smaller than 32 times 32, so that's a good thing. All over 2a, which is 2 times 6. Okay, so then I bust out the calculator. Kind of need it. So I've got a positive 32 plus or minus the square root of 32 times 32 equals 1024 minus 24 times 24 equals 576. So 1024 minus 576, oops,